All right, for this lesson, we're going to learn one of our most important skills, which is how to factor when our coefficient of x squared is something other than 1. Now, the nice thing is, if you use this method, you can use this same method instead of inspection, even when the coefficient is 1. So if it is a trinomial in the form of something x squared plus something x plus something, this method should always work if it is factorable. So, first thing we're going to take a look at is, well, if I expand it out, just like in all of our previous cases, then that should tell me what I can factor down. So if I take 2x and 3x, I get 6x squared. If I take 2x and 4, I get 8x, 1 and 3x, I get 3x, and they combine to make 11x's. And 1 times 4 is 4. So if when I multiply these out, it gives me the trinomial 6x squared plus 11x plus 4, then 6x squared plus 11x plus 4 has to be able to be factored into 2x plus 1 and 3x plus 4, which is what we're going to be learning today. At the same rate, for the next one, if I take 3x and 4x, I get 12x squareds. 3x and 3 gives me 9x. Negative 2 and 4 gives me negative 8x, and they combine to just leave me with 1x. And negative 2 and 3 make negative 6. So 12x squared plus x minus 6 has to be able to be factored down into 3x minus 2 and 4x plus 3. Now I know it does have the algebra tiles here to visually represent it, and you should be able to recognize the algebra tiles, but it's not a practical way to factor these things down. So we're going to jump ahead and look at how we're actually going to algebraically factor them down, which is the skill that is the most important for you. First thing is, part of the process is going to be factoring by grouping, which we've already covered. When we're factoring by grouping, we need to have 4 terms, like we see here, and they need to be descending by degree. So here I have a degree of 2, 1, 1, and 0. If they're not descending by degree, then it's not going to be working when we're trying to factor it. So I'm going to take the first 2 terms and pull out the greatest common factor. I can divide both these by 3, and I can divide them both by x. And when I do that, I'm left with 2x plus 1. For the second 2 terms, I have 8x and 4. I can divide both those by positive 4. And I'm left with 2x plus 1. I know what I'm doing is correct because what's left in the brackets is the same. So both the 3x and the 4 have a common factor of 2x plus 1. So I'm going to say that's going to be what's inside the brackets, 2x plus 1, multiplied by what's outside the brackets, 3x plus 4. And there's my 2 factors. When I do the same thing for the second example, 12x squared and 9x have a common factor of 3x again. And I'm left with 4x plus 3. Negative 8x and negative 6 are divisible by negative 2, and I'm left with 4x plus 3. Because what's in the brackets is identical, same signs and everything, I know I'm doing it correctly, and I can say that's going to be 4x plus 3, what's inside the brackets, times 3x minus 2, what is outside the brackets. Now, when I am factoring by decomposition, decomposition means I'm doing the exact opposite process of what I would be doing if I use the distributive property to multiply out and combine terms. And we can see that we need to, for all of these, to do like a 6x squared plus 11x plus 4. First, split up the middle term into the 2 versions of x that I can factor by grouping. Now the question is, how do we find what those 2 numbers should be? Well, one of the interesting things, if I take a look here, and I have the 6x squared and 4, like I had up here, when I multiply those two terms, I get 24 x squareds. If I take the two terms that x is split up into, and I multiply them together, I get 24x squareds. Huh. Well, if I look at the second example we did up top here, if I take that 12x times negative 6, I get negative 72x squareds. If I take 9x and negative 8x and multiply them, I get negative 72x squared. So whatever the two middle terms are, they have to multiply together to make the same thing that the outside terms multiplied together to make. But they would still have to combine together to make what the middle term of my trinomial was. So I can use this same method to factor these down. If I know that the two terms I'm going to split up the middle into have to multiply together to make the same thing as the 2x squared and the 6, I'm going to start by multiplying my a by my c. And I'm going to get 12. They also have to add up to whatever the middle term is, so I need two factors of 12 that add up to 7. In this case, it's going to be 3 and 4. But unlike when I'm doing inspection, I can't just jump to the end. I need to split up those middle terms so I can factor by grouping. So I'm going to leave the first term exactly as it was. I'm going to leave the last term exactly as it was. And I'm just going to split up that middle term to now be 3x's and 4x's, which multiply together to make that 12x squared, but add up to the 7x's. And then I'm just factoring by grouping. That's all it is. What's a common factor from the first two? Common factor from the second two. Well, the first two, I can pull out an x and be left with 2x plus 3. And the second two, I'm going to pull out a 2 and be left with 2x plus 3. Which means that it's going to be 2x plus 3 and x plus 2. If ever I'm not sure if it worked or not, I'm just going to multiply these two factors back together to see if I get my original trinomial. That's just called verifying. Do it backwards to make sure that it still adds up. Same thing with this one. I'm going to start by taking the 5 and the 2, multiply them together and get 10. I need two factors of 10 that add up to 7, and they're going to be 2 and 5. So I can say that I have 5x squared. This is going to split up into 2x and 5x. And my constant at the end is still going to stay the same. And then I'm going to factor by grouping. The only thing I can divide both the first two terms by is x. And I'm left with 5x plus 2. The second two don't have a common factor, but you can see that 5x plus 2 already matches what's in the brackets. So I'm just going to say I can divide this by positive 1 and be left with 5x plus 2. Anything is divisible by 1. So I'm going to have 5x plus 2 and x plus 1. And there's my factored form.